All right, let's dive straight into this explainer. We're going to explore an absolute paradigm shift in human history, specifically looking at how the biological sciences completely transformed. Not that long ago, biology was fundamentally the slow, artisanal field of observation. But today, it's evolved into a high-speed, data-driven manufacturing industry. The forces behind this shift are nothing short of incredible, and we're going to break down exactly how this entire infrastructure of biological sovereignty was built from the ground up. Here's our roadmap for today. We'll start by unpacking the biology bottleneck, then move into engineering the cure, digitizing the human code, the precision convergence, and finally, we'll wrap up by looking at Silicon Valley's biological hub. So, Section 1, the biology bottleneck, and what we call artisanal observation. Think back to the 1980s. Medical research was, frankly, pretty descriptive and reactionary. Scientists were mostly just observing disease mechanisms and mapping out rudimentary symptoms. If you were sick with a chronic virus back then, you were often relying on blunt force, highly toxic cocktails that were discovered through painstakingly slow trial and error. The human genome was basically this impenetrable, undecipherable vault. But flash forward to today, and we've shifted entirely to biological engineering. We have predictable, high-throughput manufacturing, fully digitized data, and these incredibly powerful single pills. We literally transitioned from just watching diseases happen to actively engineering molecular solutions. Moving right along to Section 2, engineering the cure, focusing specifically on Gilead Sciences. Okay, so the core concept we need to grasp here is the molecular mimic. When Gilead was founded by Dr. Michael Riordan, the world was caught in the terrifying grip of the HIV/AIDS epidemic. And at the time, most of the pharma industry was just blindly screening massive chemical libraries, basically crossing their fingers and hoping to find something that worked. But Gilead? They had a totally different strategy: architectural reductionism. They zoomed in on nucleotide and nucleoside analog chemistry. Essentially, they created compounds that look incredibly similar to the natural building blocks of DNA or RNA. They're molecular mimics, tailor-made to intentionally intercept viral replication. So how does this actually work in practice? Well, viruses like HIV or hepatitis C need specific enzymes to copy their genetic material so they can multiply. Gilead's absolute brilliance was exploiting that exact mechanism. First, the virus reaches out for building blocks to copy itself. Second, the viral enzyme mistakenly grabs Gilead's molecular mimic instead of a natural building block. And then, boom, the analog acts as a chain terminator. It structurally prevents the virus from completing its replication cycle. The virus thinks it's building a genetic chain, but Gilead sneaks in a terminator and completely short-circuits the whole process. Over the years, Gilead managed to fully industrialize this breakthrough. Finding the molecules was one thing, but the real game changer was the single tablet regimen. Back in the early 2000s, treating HIV meant taking a highly toxic handful of pills all day long. It was exhausting for patients, and missed doses allowed the virus to mutate and become drug-resistant. But by 2006, and later with Biktarvy in 2018, Gilead pulled off a massive feat. They co-formulated multiple synergistic antiviral compounds into a single once-daily pill. By forcing the virus to fight off multiple chemical inhibitors all at once in just one pill, they virtually stripped the virus of its ability to mutate. They took a fatal diagnosis and turned it into a manageable chronic condition. And this leads to a truly mind-blowing statistic: a sustained virologic response rate of over 95%. In 2011, Gilead dropped $11 billion to acquire a company called Pharmasset, securing the rights to a compound that would become the blockbuster drug Sovaldi. The outcome? They didn't just treat hepatitis C, they effectively industrialized a cure for a chronic, previously incurable viral plague. It was a completely radical pivot. All right, Section 3, digitizing the human code and the massive rise of Illumina. To put things in perspective, $2.7 billion. That's exactly what it cost to complete the Human Genome Project back in 2003. Before Illumina came along, genomic sequencing relied on the Sanger method. It was a painfully slow, manually intensive, and astronomically expensive technique that required massive amounts of high-purity DNA and costly chemical reagents. We knew that if we were ever going to scale genomics for real, everyday clinical diagnostics, we desperately needed a 1,000-fold improvement in efficiency. So, to slash that massive cost, Illumina developed sequencing by synthesis. Instead of reading one sequence at a time, they shatter DNA into millions of tiny pieces. They attach those fragments to a glass slide called a flow cell, replicate them into dense, identical clusters, and then, here's the cool part,
As fluorescently labeled nucleotides are added one by one, a specialized camera records the specific color emitted by each base pair. This incredibly smart setup allows the machine to read millions of DNA sequences simultaneously. The big takeaway here? They completely transformed the human genome from a mysterious locked biological vault into a highly standardized, commoditized manufacturing process. By ditching the slow manual work for this automated, camera-detected optical workflow, Illumina basically turned DNA sequencing into a high-throughput digital scanning service. The economy of scale they unleashed was so profound that it literally outpaced Moore's law for over a decade. Which brings us to Section 4, the precision convergence of drugs and data. When you put these two engines together, the synergy is just incredible. Illumina provides the real-time genomic intelligence map. Their platforms can sequence a patient's viral load and pinpoint the exact genomic mutations making that virus resistant to drugs. Then, Gilead takes that precise data and uses it as a literal blueprint for chemical engineering. They iterate and design next-generation molecular weapons, those nucleotide analogs we talked about earlier, that can fit perfectly into these slightly mutated pockets of resistant viral enzymes. Because of this incredible convergence, we've essentially birthed the era of precision medicine. We no longer look at an infection as just some generic, chaotic biological assault. Instead, we see it for what it is, a highly specific, trackable genomic interaction between a unique viral mutation and a host's personal genetic landscape. The entire game has shifted from educated guesswork to absolute pinpoint precision. And hey, if you want to know why this matters on a global existential scale, look no further than the COVID-19 pandemic. This very infrastructure became our ultimate survival mechanism. Illumina's sequencing platforms were deployed worldwide to track the evolution of SARS-CoV-2 variants in near real time, feeding genomic metadata into massive cloud databases. Gilead, tapping right into that global biological surveillance, leveraged their decades of virology research to rapidly pivot and provide remdesivir, one of the first approved antiviral treatments. Real-time data mapped the threat, and rapid chemical engineering built the weapon. Finally, Section 5, Silicon Valley's biological hub and the ecosystem effect. What's really fascinating here is the geography of this revolution. Both Gilead and Illumina planted deep roots right in California's Foster City and Peninsula Industrial Corridor. And that proximity to the heart of Silicon Valley's software and high-density semiconductor hubs is definitely no accident. Being this close allows for unbelievable interdisciplinary cross-pollination. We're literally seeing data scientists leaving the AI, gaming, and search engine sectors to take on bioinformatics roles. They're bringing high-speed algorithmic frameworks right into the foundational science of human life. Make no mistake, the biological challenge of the 21st century has officially become a data processing challenge. Because these two companies laid down such rock-solid foundational platforms, the future is rushing at us at breakneck speed. We're entering what's known as Phase 7 artificial intelligence in biology. Gilead's virology pipeline is now essentially a massive data mining exercise. We've got machine learning actively scanning for chemical inhibitors. We've got AI models tasked with synthesizing entirely new protein structures. We are staring down a near future where we can design completely bespoke small molecule inhibitors targeted at one single person's unique genomic mutations. Biology today is digitized, it's programmable, and it's driven by massive data sets. And that brings us to a fascinating conclusion for today's explainer. Companies like Gilead and Illumina didn't just manufacture single medicines or lab instruments. They completely industrialized the most chaotic domains of human existence and built the foundational infrastructure of biological evolution. They laid the tracks for the next century of human health. So, with biology now fully digitized, programmable, and driven by oceans of data, what on earth will AI engineer next? The foundation is there, and the possibilities are truly endless. Thanks for joining me today, and keep questioning the incredible world around us.